Hello guys, welcome to my channel silastutoring.com. If you haven't subscribed yet, please subscribe, like and comment so you can encourage me to post more videos and do more stuff. Okay, thank you. So today I'm going to solve the from engineering mechanics book wrote by Hibbeler, the 14th edition, and this is part of the statics. This problem is come from chapter 2 and it's problem number 2. In the other video I did chapter 2 problem number 1. They look similar except in the chapter number 2 in problem 1 they was asking us to find the resultant force, and in this problem they give us this figure right here and they're asking us if the resultant force is 500 Newton, and we already see this force right here is 700 Newton, and they tell us that there is the resultant force is 500 Newton and it is situated in the y-axis. So now we have to find F and theta. We have to find this force right here and this theta. It's kind of like the same problem. The only thing we really need to pay attention in this kind of problem, any problem that asking for resultant force and stuff, what we need to really pay attention to is geometry. Geometry, because the angle play a big role in finding solutions as for all of these problems. Okay, so you can see in the last problem that I did in the chapter 2 number 1 that I had to do some geometry, draw a parallelogram to find angles and find the force that I was looking for, because basically I had to apply cosine laws. So cosine laws and sine laws, they play big roles in solving problems, engineering problems in general. Okay, definitely for statics and dynamics. Okay, so now what can we do with this problem right here? We see that we have this 700 Newton. They tell us the resultant force is in the positive, this is positive, in the positive y-axis. So it's somewhere right here, up here. Okay, and it's equal to 500. Okay, let's say, for example, this would be the force, the resultant force, and it's equal to 500. Okay, so what do? Because we already have the force, we do this, it's basically the same step. We're just gonna draw the parallelogram according to this point, because we already have this point. Okay, so we're just gonna draw the parallelogram, and to make this more parallel right here, somewhere right here, this was F. Okay, so I'm not really bad. Okay, so and now what do we say? We know this angle. They give us this angle right here. This angle is 15 degrees. Okay, so if this angle is 15 degrees, we know that also if we make a straight horizontal line, geometrically we know also this angle is 15 degrees. Okay, so if this angle is 15 degrees, this is a right angle. And if this is a right angle, that means it's equal to 90 degrees. So 90 plus 15, this entire angle is 90 plus 15. So this angle, let's call it beta. The angle beta is equal to 90 degrees plus 15 degrees. So this angle is equal to 105 degrees. Okay, and geometrically, this angle and this angle are the same, because these two lines are parallel. So this angle and this angle is the same because these two lines are parallel and this line is vertical. Okay, so that's geometric rules. Okay, so what else can we get from that? That's the first. Okay, we know that using the cosine law from previously, we see that we can say from cosine laws that the resultant force squared, let me see, I have this force. Okay, I can say this force squared is equal to this sine squared. Because I have this angle, I'm gonna use this side. This sine squared equal to this squared, which is the resultant force squared, plus that's 700, this sine squared, which is 500 with the resultant force, plus this force, which is 700 Newton squared, minus 2 times the resultant force times 700 times cosine of beta. Okay, so that gives me that the force, if you do let me substitute. The resultant force is 500 Newton plus 700 squared minus 2 times 500 times 700 times cosine 105 degrees. Go to 959.77 Newton. So that's equal to 960 Newton. If you round it, okay? This is the force that we need. Now we need this angle theta. So that can be a little tricky now, okay? Because we don't have these two angles. We don't have these two angles, but we do have this angle. Okay, so what can we do with this? If we consider this triangle, right here, like this, okay, if we consider this triangle, that's the resultant force, and that's F. So we know that this angle is beta. That's 105 degrees. And we know that this angle is theta. But don't forget, this angle, this entire angle, this angle is theta, but this entire angle is 90 degrees. Let me call this angle alpha. So this angle alpha geometrically is equal to 90 degrees because it's a right triangle minus theta. Okay? So by the sine rules, we know that we can say that sine alpha over this magnitude right here, which is the same as this magnitude, which is the 700. So that's 700 Newton right here. We can say over 700 Newton is equal to sine of F, sine of beta over F. This is sine. So This is cosine rules, this is sine rules. Basically, sine rules says the sine of an angle over the opposite, the opposite of the magnitude that is just opposed to the angle. Okay, so it basically says sine of this angle divided by the opposite sine magnitude is equal to sine of any other angle divided by its opposite. That's also equal to sine of, let's call this angle gamma, for example, gamma over f of r. Okay, because I don't have gamma, I'm just gonna use this 2 because I don't have this angle. I have this angle and I have this angle. Okay, so this angle is 90 degrees minus theta. Okay, this gives me sine 90 degrees minus theta over 700 is equal to sine of 105 degrees over F, which was 960 Newton. Okay, so that gives us theta. And theta is equal to 45 degrees. Okay, so that would be the theta that we can plug right here to get this force equal to 960 Newton if the resultant force is exactly in the y-axis, positive y-axis, and equal to 500 Newton. Okay, so this is gonna be for chapter 2, number 2 from the Engineering Mechanics Hibbeler 14th edition, and I'm gonna see you next for the next problem. All right, thank you, peace.